my channel. In this video we are going to learn about what is meant by sorting and what are the different types of sorting techniques that we can use in the data structures, right? So in the case of the sorting, so it may be of two types. The data may be sorted in two ways, that is either it may be ascending order or descending order, right? Suppose if you consider the alphabets, so the ascending order is like in this manner and the descending order is in this manner. And if you consider the alphabets, so it is the numbers 1, 2, 3 and 3, 2, 1. In the case of the alphabets, it will be A, B, C. This is the ascending order, and C, B, A. So this is the descending order. So the given data may be either in the format of ascending order or descending order. And what is the purpose of sorting? Because that means the sorting makes the searching easier, right? Suppose if you consider a real-time example like a telephone directory, if you want to search the number of a particular person, then you can search the number of the particular person easily if the given data is sorted, okay, either in the ascending or descending order format. Or suppose if the given data is unsorted, then it will take a large amount of time. That means you have to search the entire telephone directory for that particular person's number. Similarly, you can consider another real-time example, that is a dictionary. So in the case of the dictionary also, so the given the words will be in the alphabetical manner, right, in the ascending order format, right? So if you want to search the meaning of a particular word, then you will search it based on the alphabetical order of that word, so that you can easily find the meaning of that word, okay? So if the given data in the dictionary is not in a sorted manner, that means if it is in the unsorted manner, means then it will take a lot of time to search the meaning of the word in the dictionary. We have to search the entire dictionary for the particular word, right? So in this manner we can use the sorting in the real-time examples, okay? So in this video we are going to learn about the sorting technique, that is a bubble sort. So we are having the multiple number of sorting techniques, that is a bubble sort, insertion sort, selection sort, shell sort, erratic sort, heap sort, or tree sort. So these are the different types of sorting techniques. So first of all, we will see what is meant by a bubble sort. So this is the simple and easiest sorting technique, okay? So what is meant by the bubble sort? So it compares two adjacent elements and swaps them until the array gets sorted, right? So it is going to compare two adjacent elements and swap them until the array gets sorted. So we are considering some data which is in a unsorted manner, okay, and we are going to compare the adjacent elements in the given array, and we are going to sort them if the given array is not in the particular format, okay? So it is similar to the movement of the air bubbles in the water. It is similar to the movement of air bubbles in the water, okay? So bubble sort, so why the name came for this sorting technique means it is similar to the movement of air bubbles in the water. The air bubbles will start moving from the bottom of the surface of the water to the top of the water surface, right? Similarly here the data here also gets sorted. In each and every pass, one element gets sorted and comes to the end of the array, okay? So one element will get sorted and comes to the end of the array. So that's why it is also that's why the name came here as bubble sort. Similarly, how the air bubbles comes or moves to the top of the surface of the water, okay? So this is used in the computer graphics. The bubble sort is basically used in the computer graphics applications. So there is another name called sinking sort for the bubble sort. So it is also called as sinking sort. So now let us take an example here and we will see why it is called as a sinking sort. Okay. So here, we are considering an array of elements. So this is the unsorted array element. So we want this array elements in the ascending order format. So the given data is in the descending order format. So we want this in the ascending order format. Okay. So we are having the different number of passes here. Okay. So in the first pass, so we are going to bubble the first element. So in the bubble sort, we are going to compare the two adjacent elements and swap them. So we are going to compare, swap, and then again repeat. So this process will get repeated continuously until we get the sorted array of elements. Okay. So in the phase 1, first we are considering we are bubbling the first one, that is the 50, and compare it with the neighboring element or adjacent element. So the adjacent element is 40. So we are comparing the 50 and 40. Okay. So here 50 is greater than 40. Okay. So that's why we are going to swap the elements. Right. So here the 50 is greater than 40. So we are going to swap the elements. Right. So 40, 50. Okay. So now this data is so now the bubble goes to the next element. Okay, 50. So now again we are going to compare the 50 with the neighboring element. So neighboring element is 30. So again compare these elements. So here 50 is greater than 30. Right. So in ascending order format it must be 30 and 50, right? So that's why again we are going to swap these two. So now we get 30 and 50. Okay. So again compare with the neighboring elements, 50 and 20. So 50 is greater than 20, right? So that's why we are going to again swap. So compare and swap. So 20 and 50. So 40, 30, 20 and 50. So again we are going to compare the 50 with the adjacent element, that is 10. So 50 is greater than 10. So we are going to swap these elements. So now 40, 30, 20, 10 and 50. Right. So now the last element is sorted here, right? So the last element is sorted. So this is the unsorted number of elements. So in the bubble sort, so for every iteration, for every pass, so we get the sorted element at the end of the list. Okay. So that's why it is also called as a sinking sort, because the sorted element sinks to the end of the array or bottom of the array. So that's why it is also called as a sinking sort. Okay. So now this is the first iteration. So in the first iteration of first pass, in the first pass, so we are having the how many number of comparisons here? So 1, 2, 3 and 4. So 4 comparisons are made and 4 swappings are also done here. Okay. So here the number of elements are 5. Okay. So 4 comparisons and 4 swappings are done here. Okay. So we are taking a comparison. So n-1 number of comparisons are done in the first pass. Right. 4 comparisons are done in the first pass. Right. So next in the second pass we will see how the data gets sorted. So here already the last element is sorted. So we are not considering this element here. Right. So we are going to sort the unsorted elements. So we are going to bubble the element 40, the first element 40. So we are going to compare it with the neighboring element, that is 30. Okay. So 40 is greater than 30. So that's why we are going to swap these elements 30 and 40, 20, 10. So next again we are going to compare with the adjacent element, that is 20. Okay. So 40 is greater than 20. So again we are going to swap these elements, these two elements. So 30, 20, 40, 10. So again compare the 40 with the neighboring element, that is 10. So 40 is greater than 10. So just swap these elements. So now we will get the next array of elements, that is 30, 20, 10 and 40. Okay. So now in the pass 2, the 40 is the largest element, right? So this gets sorted here. So 40 is sorted element. So now 40 and 50 are the sorted elements and 30, 20 and 10 are the unsorted elements. right? In each and every pass, so one element gets sorted and sinks to the bottom of the array. Okay. So here also we are going to have n minus 2 number of iterations, right? So here, so we are doing comparison. So 1 comparison, 2 and 3. So 3 comparisons are done here, right? N minus 2, 5 minus 2 is 3. So in the past 2, 3 iterations are, so 3 comparisons and 3 swappings are done. So next one, in the past 3. Okay. So in the past 3, so we are going to bubble the first element. So compare it with the neighboring element. So 30 is greater than 20. So again, so we have to swap. So we have to repeat this process, comparing and swapping. So 20, 30 and 10. So compare the 30 with the neighboring element 10. Okay. So 30 is greater than 10. So again swap these elements. So 20, 10, 30, 40 and 50. So now 30 gets the 30 gets sorted here, right? So now 30 gets sorted here and it joins the sorted list. So now 20 and 10 are the unsorted elements. So in the past 3 also, so we are having the only 2 comparisons are done here, right? 30 to 20 and 30 to 10. So we are comparing with the 2 elements only. Okay. So we are having the 2 comparisons and 2 swappings here. So next, in the past 4. So in the past 4, we are going to compare the 2 elements only, 20 and 10. So 20 is greater than 10. So swap these elements. Now we get the 10, 20, 30, 40 and 50. So which is a sorted array of elements. Okay. So in this manner, we are going to perform the comparison and swapping of the neighboring element. Okay. So bubbling sort means, so we have to compare and swap with the neighboring elements, and we are going to repeat the same process until the array of elements get sorted. So here total number of comparisons here. So we are considering starting from the pass 1, that is n minus 1, n minus 2, n minus 3 and n minus 4. So total number of comparisons are n minus 1 plus n minus 2 plus n minus 3 and so on. So it depends on the array of elements that we are considering. So that is equals to n into n minus 1 by 2, that is big O of n square. So it is representing the natural numbers, set of natural numbers. So n into n minus 1 by 2 equals to big O of n square. So this is the best case of the bubbling sort, and worst case and average case also is big O of n square. Okay. So here the example that we have taken is in the worst case. So the array of elements is completely in the descending order format. So this is we are considering the worst case here. Okay. So for the worst case, the number of comparisons and number of swappings will be same. But in the case of the best case, it is not like that. Okay. So the best case occurs when the input is already sorted. Okay. And worst case occurs when the array is reversely sorted. Here also n minus 1 number of comparisons in first pass, n minus 2 in second pass, and n minus 3 in third pass, and so on happened in the worst case that we have taken in the given example. Okay. So time complexity of bubble sort in worst case would be same as average case and best case. So when the input array is almost sorted and we need to swap just a few elements, so that it is called as the average case. So now let us see how the source code will be written for the given bubbling sort. So after each pass, larger value sinks to the bottom of array. So hence it is called as the sinking sort that we have seen before. So here in the pass 1, we are having the 4 comparisons, right? 4 comparisons and 4 swappings. Okay. So first we have compared the 0th index element with the first index element, and first index element with the second index element, right? You see the example. So in the first pass, we have compared with the 0th index element with the first index element. Okay. And in next step, first index with the second index element, and in the third step second index element with the third index element, and third to fourth, right? So in this manner we have compared and swapped the elements. So here we are considering this, right? So total number of comparisons are 4. Okay. So similarly in the past 2 also we are comparing the 0 index element with the first index element. Okay. So 0th index element with the first index element, first one with the second index, and second one with the third index element. The total number of comparisons are 3. Right. So similarly for the remaining passes we have calculated here. Okay. So here we are going to write 2 for loops. That is the for loop for the. So we are going to write the 2 for loops here. So first for loop is for the number of passes. So here we are having 4 number of passes, right? So for that, so we are going to write the for loop. Okay. So we are taking the total number of elements here as n. So n is 5, right? So but we are having the total number of passes are 4, right? 4 number of passes are there. Okay. So that's why. So we have to write I equals to 0 to n minus 1. So we are having the 4 number of passes, right? So n minus 1 number of passes. Okay. And next, so the next inner loop. So we are going to consider the inner loop for the bubbling. Okay. So to bubble the elements in the array, compare and swap. Okay. So for bubbling the elements in the particular array, so we are going to write the another inner loop. Okay. So here, so in the first pass we are having the 4 number of comparisons and swappings. That means so j, that is the inner loop, 0 to 3, right? So we are writing 0 to 3, and 0 to 2, 0 to 1, and only 0. Okay. So 0 to 3 means we are having the 3 number of passes here. So that is 5 minus 2. You can write the 0 to 3 as 5 minus 2. 3 as 5 minus 2. That means 5 minus 1 minus 1. So we can write the 5 minus 2 as 5 minus 1 minus 1. Right? That means, so we are considering the, in the first pass, I value is 1. So 5 minus I minus 1. Okay. Okay. So in this manner, 5 minus I minus 1. So in this manner we can write the code. So similarly for the next one, in the past 2 also, so this represents the number of comparisons. So 0 to 2. Okay. So that means 2 means, so we are going 0 to 2 means 3 number of comparisons and swappings. So 2 can be written as 5 minus 3. So 5 minus 3 equals 2, right? So that means 5 minus 2 minus 1. So 5 minus I minus 1. That is n minus I minus 1. So in this manner we can write the inner loop for the bubbling purpose in the array. So now let us see the code here. For I equals to 0, I less than n minus 1, I plus plus. So here n minus 1 means the number of passes here is 4. So 0 to 4 means 5, right? So 0 to 4 we are considering. So this for loop is, the outer for loop is for the number of passes in the bubble sort. And for 0, j equals to 0, j less than n minus I minus 1, j plus plus. So this is for the bubbling of the array of elements in the given array, right? So we are going to bubble the particular element, okay, and then compare it with the neighboring elements. So if the given bubbled element is greater than the neighboring element, right? So j is greater than j plus 1. That means, so in the first pass we are going to compare the 0th index element with the first index element, okay, and first with the second one, the neighboring one. So similarly here, so we are going to consider the array of j. So 0th index element with the j plus 1, that is 1. So we are comparing the array, the 0th index element with the first index element. and one first index element with the second index element. Okay, so if it's greater, right, if the zeroth index element is greater than 1, if the zeroth index element is greater than 1, then we are going to compare. So we are going to swap these elements, right? So we are comparing first 0 is greater than 1 or not. If it is greater, then we are going to swap these elements, right? So we are going to swap these two elements. So this is the code for swapping the elements. Okay, so in this manner we can swap the elements in the bubble sort. So what is the advantages and drawbacks of the bubble sort? It is simple and easy to implement. So it is a basic sorting technique and it is very simple and easy to implement. And there are some drawbacks for the bubble sort. Okay, so it runs slowly because so we have to search. If you are having the large amount of data, right? If you are having the large amount of array of elements, suppose 100, 200 like that, so it will take a lot of time to compare the adjacent elements, right? So if there are 100 number of elements, then we have to perform 50 or 50 comparisons, right? We have to perform the most number of comparisons and swappings. So it runs slowly. And the next one is, even if elements are sorted in n-1 passes, so even if the elements are sorted in the given list, we have to perform the n-1 number of passes, right? So this is also one of the drawback of the bubble sort. So when input array contains large number of elements, the efficiency of the bubble sort decreases gradually. Okay, so that is the main drawback of the bubble sort. So bubble sort is also called as a sinking sort or exchange sort. Okay, so this is the basic sorting technique. And this is all about the bubble sort. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.